today we're going to be talking about inverse functions. We already know what a function is. We've talked about various functions before. In today's class, an inverse function is really the reverse of the original function. I'm going to go through all of the definitions, which might not make sense to you, but as we do the examples, as always, it'll become a little bit more clear. The domain and range are interchanged for a function and its inverse. That means the domain of the original is the range of the inverse, and the range of the original is the domain of the inverse. Again, it'll make sense when we do examples. Not all inverse relations are functions. Keep that in mind. If the inverse of a function is a function, then we use this symbol to denote that it is the inverse of a function. And I cheat a little bit because if the inverse of a function is not a function, I use this. So I use y -1. I don't know if this is like common practice. It's something I do because I think it makes the questions easier. You may never see it again, and your grade 12 teachers may be like, what is going on? Just don't tell them I taught you this. It's just something for our class just for this year. And the symbol f -1x is read as f inverse of x or inverse of f at x. I do want to tell you that even though it's a little -1, that's not a negative exponent. So don't confuse it between this example here. Like when we learn 2 to the power of -1 is 1/2, that does not mean f to the power of -1 is 1 over f. It just means it's an inverse of a function. Okay, so that is like the formal stuff. Let's get into examples, which I think always help explain stuff a little bit better. So I have a function and it has the following points: -2, -8, 0, -2, 3, 4, and 4, 7. And I want us to figure out the inverse of this function. And the way we figure out the inverse of a function is we just interchange the x and the y. So in this example, when I interchange the x and y, I'm going to get -8, -2, -2, 0, 4, 3, and 7, 4. And that's literally it. That's how you find the inverse of something. You just switch the x and the y to give you the inverse. Now, our original function was a function. However, we're trying to figure out if this inverse is a function. And I want you to think back to our previous unit where we were talking about functions and relations. And when we had a bunch of different coordinates, the way we determined if something was a function is we looked at all of the x's. And if we had repeating x's, then it was not a function, it was a relation. In this example, though, we have a -8, -2, 4, and 7. Nothing repeats. So is this a function? Yes. So we're going to say, therefore, the inverse is a function. And now we can use the the terminology f -1x. If it was not a function, we could not use this and we would have to use y. Okay, so this is what you do when you have a bunch of different points and you're trying to figure out the inverse. Any questions? You okay? All right. What about if I give you a graph and I'm asking you to sketch the inverse of this graph? So what I'm going to do first is I'm going to make a table of values. And on the left-hand side, I am going to figure out what my original points are on the original graph. So this might bring back really fond, happy memories of the last unit. We have these 5 points. So -3, 0, -2, 1, 0, 0, 1, 2, and 3, 0. Okay, now on the other side of the our table of values, I'm going to figure out the inverse. And what do I do for that? I just swap the x and y's. So this is going to be 0, negative 3, 1, negative 2, 0, 0, 2, 1, 0, 3. Now, before we try to figure out if this is an inverse or not, I mean, if it is a function or not, we can figure it out just by looking at the x's. Let's graph it and see what happens. So 0, negative 3, 1, negative 2, 0, 0, 2, 1, 0, 3. If you have a ruler, use a ruler and graph and draw your lines. We take a step back. We look at our graph. Is this graph a function or not? It's not. And how do you know this? It doesn't pass a vertical line test. So I can't use f of -1. I'm going to use y of -1 just to tell me that it's not a function, it's a relation. And we can also write at the top over here where it says, is it a function? The inverse is not a function. Now here's a little fun fact. If you're trying to visualize what exactly the inverse is reflecting upon, it's not the x-axis, it's not the y-axis, it's actually the y is equal to x-axis. So imagine that you're drawing a line y is equal to x, which is just literally up 1, 1 to the right, up 1, 1 to the right. And I'll just show you that on here. So So if you have a ruler, you could probably do this a little bit easier than me, but I'm going to draw a dashed line like this. And I'm going to label this y is equal to x. And once you draw that diagonal line, I'm hoping now maybe you can see that the graph is reflecting upon that diagonal line. It might not be so obvious with this weird squig, like zigzag line, but when we do other graphs of parabolas and stuff like that, you will be able to see very clearly it's flipping over this line. Any questions about this stuff? Okay, so we have figured out how to determine the inverse of a bunch of points. You just swap them. We now know how to find the inverse of a graph. You figure out the main points on the graph and then swap them. Let's move on to how to determine the inverse algebraically. I have a feeling you're going to like this because it's not too challenging and it just makes good sense. So here are the steps we're going to follow. Step number 1, we're going to replace the f of x with the y. Step number 2, we're going to switch or interchange the x and the y. Step number 3, we're going to solve for y. And then we're going to determine if we're using f -1x or y -1x. So if the inverse is a function, we're going to use f -1x. If it's not a function, we will not be using that notation. Okay, so let's try this. Step number 1, you replace the f of x with a y. You're going to get y is equal to 4x plus 3. Step number 2, you swap the x and the y. So wherever you had the y, you're going to put in an x. And wherever you had an x, you're going to put in a y. Step number 3, you're now going to solve for y in this newly switched equation. So this is like grade 9 algebra techniques. You move the 3 over, you divide by whatever number is in front of the y. So I'm going to get x minus 3 is equal to 4y. I like to swap everything around. Like I like when my y is on one side. So I'm just going to rewrite it. You don't even have to show the step. I'm just trying to be super thorough. And then y is going to be equal to x minus 3 over 4. You guys, another way to write this is y is equal to 1 over 4x minus 3 over 4. Both of these are correct. It doesn't matter what form you write it in, personal preference, whatever you choose. Okay, so this is our equation of our inverse. Let's take a look at it. Is this inverse a function. Now, we don't have the luxury of having a visual. We can't actually see it. But what kind of equation does this resemble? What is this? It's just I think you said it, I just didn't hear you. Not rational. Think of y is equal to mx plus b. Does it look like an equation of a line? Because it is. So this equation is just that of a line, and every single line it'll always pass the vertical line test. So this is going to be a function, and we're going to rewrite it. So it's f negative 1x is equal to, and it doesn't matter what form you write it in. I will just keep it in this form. That would be your answer. Does this make sense? Question? Yeah. 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 Any questions about it? Okay, and we're gonna do 3 examples and then another back page of examples, and then we're done. But hopefully by like the 3rd example, this starts to make really good sense to you guys. Okay, let's try question number letter B. We have we replace the f of x with a y, so we're gonna get x minus 2 over y is equal to x minus 2 over 3. I'm going to interchange the x and the y, so it's going to be x is equal to y minus 2 over 3. To get rid of the 3, you can use the magic number, so you can kind of multiply everything in the equation with 3. I'm just going to put a dot there. So when you do that, you end up getting 3x is equal to y minus 2. I need to get rid of the negative 2. I'll move it over to the other side. It'll become positive 2. So I end up getting y is equal to 3x plus 2. What kind of equation is this? Yeah, it's definitely a line. And every line is going to pass the vertical line test. So we can rewrite this with the proper notation. F negative 1x is equal to 3x plus 2. By the way, if you're wondering, what if I just left the answer like this, y is equal to 3x plus 2, you would lose marks because that doesn't even tell me it's an inverse. I need you to tell me somehow that what you have found here is the inverse of the function. If you wanted, you could write a sentence, but really use the notation. And that then is the final answer. It tells me you figured out the inverse. Okay, let's keep going. Question C. The theme of today's handout is cute animals. So y is going to be equal to root x minus 1 plus 3. You are going to switch the x and the y. So it's going to be x is equal to root y minus 1 plus 3. I'm going to move the 3 to the other side, but I'm also going to bring the root over. So I'm going to do 2 steps in one. I'm going to write this as root y minus 1 is equal to x minus 3. So really, I move the positive 3 to the other side. I got x minus 3. Then I flip everything around, so my variable is on the left-hand side. What do you do at this step? How do you get rid of a square root? Yeah, the opposite of a square root, exactly, is a square. So what I'm going to do is I'm just going to put brackets around both of these terms, and I'm going to square everything on both sides. And when I do that, I'm going to get just y minus 1 over here because a square root and a square cancel each other out. And on this side, I'm going to be left with x minus 3 squared. I'm going to move the 1 over, so I'll get x minus 3 squared plus 1. What is this an example of? Yeah, it's an example of a parabola. So you're going to move 3 units to the right, 1 unit up. The parabola opens like this. Does this pass the vertical line test? Yes, it does. So this is a function. In fact, I'm just going to write down parabola over here. And so we can use the notation f negative 1x is equal to x minus 3 squared plus 1. Okay, last example on this page. Whenever there is a variable in the denominator, it can be challenging if you don't like pay attention to it. So I guess this last question is probably the hardest. We have y is equal to 2 over x plus 1. Interchange, so it's going to be x is equal to 2 over y plus 1. Move the 1 to the other side, so it's going to be x minus y is equal to 2, sorry, x minus 1 is equal to 2 over y. Okay, this is how I would solve this question. I either multiply both sides by y or just recognize that I'm moving the y to this side. So it's basically going to be y bracket x minus 1 is equal to 2. And then you can divide by x minus 1. Do you need to show this intermediate step? You don't have to. If you can go from this step over here to the answer and you can see y, that's totally fine. But it would be y is equal to 2 over x minus y. You guys, what kind of graph is this? Yeah, oh, good job, you remembered. This is a rational function. So just as a reminder, well, this means we have an asymptote at x is equal to 1, and the graph is going to look like this, and the graph is going to look like this. Does this pass the vertical line test? Yeah, it does. It doesn't have like any part where there are two values for the same x. So it does pass the vertical line test, and you can write f negative 1x is equal to 2 over x minus 1. You guys remember how much you loved function notation? It's back. And it's back with inverse, so it's even more fun now. All right, let's start this question off by reading it. So the question says, if g of x is equal to 2x plus 3, find the inverse of g of x and then evaluate. So we'll get to the evaluating part in a second. Let's first find the inverse of g of x. We just practiced 4 examples of this, and this is a pretty easy equation. So this will be pretty easy. We're going to go y is equal to 2x plus 3. You always replace your function notation with y. Then you swap the x and the y, so it's going to be x is equal to 2y plus 3. 2y is going to be equal to x minus 3. And then y is going to be equal to x minus 3 over 2. Or you could write it as y is equal to a half x minus 3 over 2. What kind of equation is this? It's definitely a straight line, so it definitely passes the vertical line test. So therefore, when we write it in proper notation, we're going to write g negative 1x. So the inverse of g of x is equal to, and it doesn't matter which one of those you pick, whatever you like. I'm going to pick this one. Okay, now here is how I want you to think about this question. I like to think that I have 2 different equations here. I have the OG equation here, the original equation, and then here I have the inverse. And when I'm evaluating, I have to see what the question is asking us for. So look at question A. It just says g of negative 2. Is this asking us for the original equation or the inverse equation? The original, and how did you know that? There's no inverse. How about the next one where it has the little -1 signs? What is this asking us to input it into? Good. So for these two examples, we are going to be inputting the value into the inverse equation. And for the first one, we're going to be inputting that into the original equation. And that's really it. There's nothing else different, no other calculations. You're just selecting which equation to put it in and then solve. Okay, so given all this information, let's go ahead and try this. For the first one, g of -2, we are going to we're going to use the original. So this is going to be like g of -2 is equal to 2 bracket -2 plus 3. That's going to be equal to -4 plus 3, which is going to be equal to -1. That was a pretty easy, straightforward one. Let's try the next one. For the next one, we're using our inverse. So we're going to go the inverse of 3. And now we're going to be plugging in that 3 into the inverse equation. Okay, so let's put this into the inverse equation. It's going to be 3 take away 3 over 2, which is just going to be 0 over 2. And that's going to give us just a 0. Did you guys get that already? I know you're ahead of me. You did? Okay, and then for the last one, we have the inverse of g at 2x plus 3. So for this one, we're going to be substituting in 2x plus 3 into our inverse equation wherever we have an x. So see how there's an x here? We're going to replace that into there. Okay, so that's going to be 2x plus 3 minus 3 all over 2. That's going to simplify to give me 2x plus 3 minus 3 all over 2. That will simplify to give me 2x over 2. Should you guys just get x as an answer? That would be your final answer. Not too bad, right? Are we enjoying inverse? Okay. Or we're not enjoying it, but we're understanding it? Okay. The last question, you guys, look at that, how cute that cat is. I want you to highlight this question because this can be a little bit of a challenge. You're definitely going to see it again on a test. And if you don't at least review it before a unit test, it can be confusing. And the only reason for that is as soon as I feel like we introduce another letter, it just throws you guys off. Another letter, I know, it's not a variable, it's just a letter. So given f of x is equal to -2k plus 3x, find the value of k if if the inverse of f at -5 is equal to 7. That seems really confusing, but really my strategy here is I have an equation that's f of x, and I see the notation of inverse of f, so I definitely know I need to find the inverse of this equation first. Another helpful hint for you guys is, see this letter k? Don't think of it as a variable. Think of it as just another number that we're trying to find. We don't know what the number is, but there's only a y and an x in this. The k is just a number. So to solve this question, I'm first going to remember my steps. It's going to be y is equal to -2k plus 3x. I'm going to switch the x and the y. So it's going to be x is equal to -2k plus 3y. I'm going to move the 2k to the other side. So it's going to be x plus 2k is equal to 3y. And then y is going to be equal to x plus 2k all over 3. Or another way to think about it is y is equal to 1 over 3x plus 2 over 3k. The only reason I find this a little helpful is because you can very clearly see that when you write it like that, it's y is equal to mx plus b. So for sure, this is a line and it is going to be a function. So we can write it with function notation. And then it doesn't matter which equation you pick. I will just pick this one. inverse of f of x is equal to x plus 2k over 3. Okay. Now that we know this, let's actually just break down what is happening in this part of the question. In this part of the question, they are saying the inverse of f, what variable does that -5 represent? Good. So this is telling me x is equal to -5. And what letter does the 7 represent? Or what is it equal to? The y. So whenever you have, for function notation, like even if I were to write with regular notation, this is always your x value. This is always your y value. As long as you remember that, then this question becomes really easy, because you break it down and you say, okay, x is equal to -5, y is equal to 7. And because they're using the function notation, the inverse notation, I know the equation I'm going to have to use to plug these numbers in is the inverse function. And that's great, because if I plug in x and y into this, then I can solve for k. Okay, so how is that going to look? By the way, what is the y in this? Well, the y is just that f of -1x, right? Because it was originally a y and then we replace it with function notation. So both of those are interchangeable. They mean the same thing. Okay, so wherever I have my y, I'm going to put in a 7. Actually, let's begin by writing out the equation just so that you can see where everything is going. X plus 2k over 3. So my 7 is going to go on this side. My -5 is going to go where my x is. And this is great because now I can clearly see that I only have one letter to solve, and that should give me my final answer. So 7 times 3 is 21. When I move the 5 over, it's going to become a 26. And when I solve for this, it's going to give me the number 13. So this tells me our k value is 13. For sure, a challenging question if you've never seen it before. Like in the past, we always used to give this as like a thinking question or an application question, but I'm just showing it to you so you guys are well prepared. Does it make sense? Everything good with this? You guys see that first page that I gave you? It's an exploration activity. It was meant to be like before we did the lesson, but I feel like it can be a little confusing. So I'm going to actually give you that for homework. And then the other sheets for homework are handout B, which I have here. So I'll show it to you guys online. And also I have already posted the answers to handout B. So they're already on Brightspace. So do handout B, you can do the first sheet as well. And then there's some textbook questions for you to try. You guys have a ton of time right now. You have 40 minutes. So be productive. I know it's last period, but just try to get some of this done. Okay, so for you guys at home, this is the first page of handout B. And this is the second page.